Hey guys, welcome back. Here we go, lesson 111. So applications using division. So this lesson is actually not going to be new content. You guys know how to divide, okay? This is not learning a new process. This is just learning how to use some reasoning skills that you already have to help you do problems, work problems with skills that you already have, but just kind of using some logic, like common sense, to help you determine what kind of answer is best. So when we divide, there are three main options for writing your answer that you guys have learned. The first of those is a remainder. Okay, so we could have, let me set this up for us real quick. Okay, so we could have a problem like 15 divided by 4. Okay, well, I'm not going to spend a lot of time talking about division because you guys know how to divide. So I'm going to go through the division problems pretty quick, but then we're going to talk about the answers and why the answer matters and how you can tell which type of answer to give. Okay, so 4 goes into 15. 3 times. 3 times 4 is 12. 15 minus 12 is 3. Okay, so there's the first answer option where we just put the remainder as remainder 3. Okay, that's how we write our answer as a remainder. We could take that same answer and we could say, okay, well, my answer was 3, but then we could take this remainder and make it the numerator of the remaining fraction, and using that divisor over there, the 4, as the denominator. That is how we write the answer as a mixed number, okay? Then finally, the last way that we write the answer to a division problem when it's not a whole number is as a decimal. So let's just kind of rework this real quick so you can see how this would play out. So we would get to here, but then we would add a decimal and a 0 and keep going. Okay, so we're going to bring that down. So 4 goes into 30 7 times. 7 times 4 is 28. We'll subtract that. Okay, and then that will get 2. We're low on room down here. And we can bring another 0 down, and 4 goes into 25 times. Okay, so that ends up being 3.75, sorry. And so that is actually going to be our decimal way. So all three of these, here's what I want you to see. All three of these answers are the same. They are just different representations of the same thing. One is a remainder format, one is a mixed number format, and one is a decimal format. So how do we know when to use which one? That's a great question. That's what we're here to do today. And we're also here to talk about when you need to round it to a whole number, okay? And which way to round it, up or down, based on the situation. So let's look at some examples. It's really the best way to do this lesson is just to work through these examples. So the first example is 100 campers are to be assigned to 3 campsites. How many campers should be assigned to each campsite so that the numbers are as balanced as possible? Okay, so we can see from our problem that we've got 100 campers and they are being assigned to 3 campsites. So we're splitting 100 campers up among 3 sites. So 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down the 0. 3 goes into 10 3 times again. 3 times 3 is 9. That's a 3. I don't like the way that looks. Now it looks worse. Sorry about that. 3 times 3 is 9. 10 minus 9 is 1. I think you can see a pattern here. So if we stop there, though, remember, we can say, okay, my answer was 33. And then remember, I can take this remainder and write it as my numerator over my divisor, which is my denominator. So I could say 33 1/3. All right, so let's look back at the question. Before you put a box around your answer, you always want to look back at the question and say, okay, did I give the answer that they were looking for there? The question is how many campers should be assigned to each campsite so that the numbers are as balanced as possible. So we've got 3 campsites, okay? Campsite number 1, campsite number 2. I'm not sure what's happening with my pen. There we go. And campsite number 3. Okay. So, there we go. So if I know that they are 33 1/3 as a result, then I know that I could put 33, like I could just round down and say, well, I know I could put 33 campers at each one. But that's just going to give me a total, if I add them all up, that just gives me a total of 99. But I have 100 campers. So what do I do with that one extra camper? Well, I can't just get rid of him. I mean, I guess I could, but that wouldn't answer the question that they're asking. It says, how many campers should be assigned to each campsite so that the numbers, all the numbers that are given, are as balanced as possible. So in order to keep things balanced, I can have 33 in each, but I've got to add that one extra on somewhere. Okay, so then the number of campers on each to keep it balanced would have to be 33, 33, and 34, because then that would add up to 100, which is what we want. Okay, awesome job. Let's look at another one. Okay, movie tickets cost $4. Jim has $15. How many tickets can he buy? Okay, we already did this basically because it's 15 divided by 4, and that's what we did in the beginning example. So, excuse me, let's just run through this real quick. That'll be 12, subtract that, that'll be 3. Okay, so the answer would be 3 3/4. Now, can you buy 3/4 of a ticket? No. I don't think they're going to let you sit through 3/4 of the movie if you don't have quite enough money. You have to either buy a whole ticket or no ticket at all. So the amount that he has to buy 3 tickets, that's enough to buy 3 tickets. The 3/4, however, is not enough to buy a ticket. So you don't get any ticket out of that. So then if you put that together, you're just going to end up with 3 whole tickets that he can buy. Okay, so again, it's just reasoning. It's just thinking about the situation. What makes sense here? Does it make sense that he could use that extra 3/4 to buy a whole ticket? Well, no. If you don't give them enough money for an entire ticket, they're not going to give you anything. They're not going to give you they're not going to like tear a piece of the ticket off and be like, here you go, you can watch half the movie. You had to pay for a whole ticket or none. Okay, so we want to just think reasoning about those things when we're solving problems like this. Okay, let's look at the next one. What about 15 children need a ride to the fair? Each car can transport 4 children. How many cars are needed to transport 15 children? All right, same problem again, but the situation is a little different. So I'm just going to run through this really quick because you guys already know this. We already did this. That's going to end up with 3. So again, we're at 3 3/4, okay? Now, last time we said the 3/4 doesn't count, okay, because you can't buy a whole ticket. This time, we need a certain number of cars to transport kids, okay? So 3 cars are definitely needed, but then we still need 3/4 of a car. We rent 3/4 of a car? No. So if we can't get 3/4 of a car, but we got to have more than 3 cars to transport the kids, then obviously 3 cars is not enough. So you would have to get one more to represent that 3/4 that's left over. So that means you would have to get 4 cars. Okay, so same exact division as the last problem, but different answer based on the circumstances. Okay, so always just think it through. Think it through logically. What would I do if I was in this situation and I had to figure this problem out? Okay, apply it to what you know to be true. Okay, you guys are so smart. I know you can do this. One more. You're doing awesome. 4 workers were paid a total of $50 for cleaning a yard. If the workers divide the money equally, how much money will each worker receive? Okay, so $50 divided equally among the 4 workers. Now, we are talking about money. It says how much money will each worker receive. Remember, when we are talking about money, money is always written as a decimal. Okay, so we would want to keep going here in order to get a decimal answer. So I can know that from the get-go, and that's going to be helpful. So 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. Bring down that 0. 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. Now I'm going to add a decimal 0 because, again, we're talking about money here. So we want our answer to be in a decimal. 4 goes into 20 5 times. 5 times 4 is 20. Subtract that. That leaves me with nothing. Okay? Now we're talking about money here. So this doesn't quite look like money to me because money always has 2 digits behind the decimal. So remember, I can add a 0 there at the very end and it will not change the value. So that means that each worker would get $12.50. Great job, guys. Just problem solving, reasoning, just thinking through what makes the most sense. I know you guys got this. Happy homework.